Not every beach can be landed on. Someone has to confirm that first. From late 1944 to mid-1945, the United States conducted a series of large-scale amphibious landings across the Pacific. Each operation took place on a different island, but all faced the same risk. No one could be certain that the beach would actually allow landing craft to reach shore. Nautical charts lacked detail. Aerial reconnaissance could not reveal reefs below the surface. Naval gunfire could not remove obstacles underwater. If landing craft grounded offshore, troops would be forced into the water too early and exposed before reaching land. To prevent that, the U.S. Navy needed a force to approach the beach before the operation, to confirm water depth, reefs, and obstacles invisible from a distance. That task belonged to the underwater demolition teams. Their work did not happen in a single approach. They swam in at night, measured depth, identified obstacles, and withdrew offshore. Once obstacles were mapped, they returned, placed explosives at specific points, and cleared the area before the landing window. They were not assigned to fight on the beach. They were assigned to decide whether a landing could happen at all. Their loadout did not exist for combat. It existed to endure cold water, operate in darkness, and return again and again until an unknown shoreline became a usable landing beach. Item 1. Thermal protection. As soon as the mission begins, the team enters the water and swims from offshore toward the landing beach. UDT operators remain in the water for hours. Prolonged exposure to cold seawater rapidly lowers body temperature. Hands and feet lose sensation. To slow heat loss, grease is applied directly to the skin as a passive thermal barrier. This method preserves mobility, maintains feeling in the limbs, and allows the operator to keep working underwater for the full duration required by the mission. Item 2. Thermal underwear. During extended operations, UDT personnel remain exposed to cold even while waiting offshore. Thermal underwear worn close to the body helps retain heat when physical movement is limited. It supports sustained performance across multiple approach phases. Item 3. Swim attire. During the long swim in from offshore, reducing drag determines whether energy is preserved or exhausted before reaching the work area. Short swim trunks remove excess fabric, allow free movement, and do not interfere during extended swimming. They help maintain a steady pace throughout the approach. Item 4. Swim fins. Over long-distance swims from offshore, consistent propulsion determines whether energy remains available upon reaching the task area. When carrying equipment and moving against current, fins allow the team to arrive with enough strength to continue underwater work. Item 5. Diving mask. During underwater operations, continuous visual observation determines whether obstacles are correctly identified. If visual rhythm is broken, the team must rely on touch, losing time at the point of contact. The mask preserves observation and reduces uncertainty. Item 06. Oxygen rebreather. For missions that require extended underwater work or absolute concealment, UDT uses a closed-circuit oxygen rebreather. The system recycles exhaled gas, removes carbon dioxide through a chemical filter, and produces no bubbles at the surface. This allows the operator to move and work in shallow water in complete silence while approaching areas under enemy control. However, this is not mandatory equipment for every mission. For short reconnaissance tasks in very shallow water, UDT often approaches by breath holding, without a rebreather, to reduce load and maintain movement speed. Item 7. Demolition charge. When UDT identifies man-made structures placed underwater directly along the landing craft approach path, the mission shifts from reconnaissance to immediate removal. These structures sit in shallow water and are rigid enough to ground or deflect landing craft. Flexible charges are wrapped tightly around the base of the structure at the primary load-bearing point. This placement concentrates force on the structural weak point. Once that point fails, the structure collapses in shallow water and no longer obstructs the approach. The Hagensen pack enables rapid removal of artificial obstacles directly along the confirmed landing route without forcing craft to stop or divert. Item 8. Demolition charge number 2. At many beaches, the obstacle is not a constructed object, but solid natural rock or coral reef. These formations have no posts, no anchors, and no discrete load points. They exist as continuous mass just below the waterline. Solid tetral blocks are inserted into natural cracks or at the base of the formation. Placement inside the material allows explosive force to propagate inward. When detonated, the solid structure fractures from within, breaking continuity at the treated point. Tetral blocks defeat natural obstacles that lack anchor points by collapsing the mass internally. Item 9. Initiation System. The initiation system allows multiple charges to be linked into a single firing circuit. Detonating core transmits the impulse from the initiation point to all placed charges. This allows the team to clear the area, swim to a safe distance, and initiate the blast remotely. Item 10. Waterproof demolition carry. Explosives and initiation components must be carried throughout the swim and underwater work phase. Waterproof bags protect charges, caps, and detonation cord from seawater exposure. They ensure the explosives function correctly at the moment of placement, without requiring on-site correction. Item 11. Cutting tool. The knife is carried to deal quickly with soft materials at the underwater work site. It allows lines, nets, or unexpected entanglements to be cut immediately, without forcing the operator to stop or change the primary task. In an environment where every second underwater is limited, instant release matters more than sharpness or lethality. Item 12. Measuring and recording tools. A measuring line is used to determine exact water depth at each survey point. A weighted plumb is dropped to the bottom. Depth, slope, and seabed profile are read directly from the line. Results are written immediately on a slate, along with obstacles, irregularities, or notable features of the seabed. These records become the direct basis for demolition planning, obstacle clearance, and landing lane selection. Item 13. Timing device. The watch controls time throughout approach and withdrawal. It tells the operator how long they have been underwater and how much margin remains before safety limits are reached. In shallow water work where tasks can easily run long, the watch keeps the operation within the planned time window. Item 14. Securing cordage. Cordage is used to secure personal equipment and prevent light items from drifting away. Tools can be clipped, tied, or temporarily anchored in place, reducing loss caused by currents or surge. Every recovery attempt underwater costs time and energy. Cordage removes that risk before it appears. Item 15. Emergency flotation. Emergency flotation is carried for unplanned situations. If an operator is exhausted, injured, or encounters a problem underwater, it allows them to remain afloat without continued swimming or effort. It creates a survival window, long enough to receive assistance or withdraw from the area safely. Item 16. Marking tools. Marker floats are deployed after obstacles are cleared, but before the landing force approaches. The floats carry yellow flags, highly visible on the surface, marking the exact safe lane for landing craft. Deployment usually occurs 1 to 2 hours before H hour, under naval gunfire smoke and cover. In limited visibility, these markers are often the only guidance that leads landing craft to the correct approach lane. Underwater demolition teams are not remembered for fighting on shore. They existed to answer one question before any operation began: can this beach be landed on? Their loadout was not designed to maximize firepower. It was built to endure cold water, to work in darkness, and to return again and again until the answer became clear. Once the underwater obstacles were gone, the landing could proceed as planned. And when troops reached the beach, UDT's task was already finished. Not on the shore, but offshore, in silence.